AGI-14, I think. Actually, most of you were here yesterday for the tutorial day anyhow, but for those of you who weren't, welcome. I'm going to give a few minutes of introductory remarks for the conference and then introduce our first keynote speaker. So, being an AGI optimist, I can't say I'm surprised by the renewed enthusiasm for general intelligence, human-level AI, and other ambitious incarnations of the AI dream that we're seeing this year, last year, and increasingly in the recent past. It doesn't surprise me, but it still excites me, and I think it's a very exciting time for all of us to be doing this kind of work, and it's worth reflecting on how different the atmosphere is now that we're gathered here together for AGI-14 compared to, say, 10 or 20 years ago. So there's been a lot of progress both in science and engineering and in terms of just the field and the public at large and their way of thinking about these topics. I mean, in the mid-1980s, when I was choosing a PhD topic, I wanted to do a PhD on something related to human-level intelligence, and I got very interesting reactions from potential PhD supervisors, but not particularly positive ones. And then I wound up doing my PhD on a more conventional topic. I mean, I was in the mathematics department. It was something on the optimization of nonlinear functions in infinite dimensional spaces. It was very interesting, but it was clear at that point it would have been very hard to find a supervisor who took anything related to AGI or human-level AI seriously as a topic for real research. And even 10 or 12 years ago, that was still significantly the case. I mean, I remember going to an AGI conference, I think that was 2003 in Acapulco in Mexico, and I met Nick Casamatis there, who works at RPI, and he was interested in human-level intelligence, and that was like meeting a secret co-conspirator or something, because there were very few people that you could talk to in the hallway at that AGI conference who had a deep interest in that topic. Yeah?
So when was it you started your PhD?
85. Yeah, I'm old. Yeah, started in 85, finished 89 in mathematics, and then gradually deviated to cognitive science and AI over time.
You just went to the wrong school and the wrong major.
Yeah, well, that was intentional, because seeing what was taught in the AI courses at that time felt like the wrong direction to me. So I sort of went into math because I figured math would be useful pretty much for anything I wanted to do in the future. It seemed like a universal language, and certainly for any kind of AI that would interest me, it seemed like it would involve math. But yeah, in hindsight, I probably had too harsh an attitude toward the AI of that time. But at the time, I really had little interest in expert systems, which was what there was a huge amount of noise about then, and that seemed like just profoundly the wrong direction to be taking. Anything where you're hand coding rules of knowledge for your system just felt wrong to me. I really wanted to be focusing more on self-organization and learning, and that there wasn't too much going on in that regard at that point in time. Although, of course, in hindsight, when you trace the literature back, you can see there were loads of people working on these things all through. But there was also no internet then that was accessible to a grad student or an undergraduate, so it was much harder to find the oddball people working on interesting stuff all around the world at that time. I mean, you actually have to go to the library and look at paper journals and try to find out what people were doing. It's quite archaic. So, I mean, the scene was definitely quite different there anyway. I mean, you would walk around an AI conference or a computer science department and pretty much, except for a few odd people here and there, the idea of building human-level thinking machines was considered more a science fictional thing that had indeed inspired the founders of the AI field back in the 50s and 60s. But then the general attitude seemed to be that now the field was older and wiser and realized that was really, really hard and lay an indefinite distance of time in the future. So that the real business of AI had to do with quite different sorts of things. And I mean, I drifted out of academia into industry, and then I guess in the beginning of the century, 2001, 2002, started to verge back toward academic research again, and then I became interested in general intelligence as an academic research topic, as well as a subject of practical system building. And then my colleague Cassio Panachian and I started putting together an edited book on artificial general intelligence, and that brought me in touch with Marcus Hutter and his whole way of thinking about the mathematical formalization of AI. And then I realized there was a whole other train of thought about AGI that had been going on for quite a while, which I'd been aware of Solomonoff induction and some related ideas, but I hadn't known that people had been working on that actively and building into more of a mathematical theory of AI. But still, at that point, the AGI or human-level AI community, such as it was islands of disparate people working on very particular things. I met Peter Vos, who's in the audience here, around that time as well. He submitted a paper to that book. He's been working toward AGI in a commercial context since then. Now, when I got the crazy idea to organize an AGI conference for the first time, it was actually the 0th AGI conference in 2006, which was called the AGI workshop in Bethesda, Maryland. And there's a few people here who were at that one as well. Mark Wasser, for example. And so, at that point, it still had a very maverick feel, like a bunch of folks from out of the mainstream, come from all over the country, some from Europe or Asia, and I mean, we're gathered in a hotel in Bethesda, Maryland, and sort of plotting, making, thinking machines. And it was very clear that you wouldn't have a workshop like that within a triple AI conference. It wasn't taken very seriously at that point. And I mean, things have changed gradually since then. There's been no huge event that really made a large difference, but things have changed little by little. And what we've seen over the time since then, not only the AGI conference series has sprung up, we have the BICA conference series, Biologically Inspired Cognitive Architectures. There's the Cognitive Systems Conference from Pat Langley and his colleagues. And within the IEEE and AAAI conferences, you now have loads of symposia, workshops, special sessions dealing with human-level AI, cognitive systems, whatever you want to call the grand original goal of AI, building thinking machines that can think like people. And it's no longer a marginal sort of pursuit. And part of what's happened also is industry has gotten into the picture. I mean, as we all saw, Google acquired DeepMind for something like $400 million, which was founded by Demis Hassabis, who is very much an AGI researcher, and Shane Legg, who also has been. He worked for my first AI company in the late 1990s, and then he was Marcus Hutter's PhD student before he moved to the UK to join DeepMind. And DeepMind isn't the only example, of course. You have Vicarious Systems has now been well funded, and Darlene George gave a keynote at last year's AGI conference. We can see big tech companies now, not just IBM with Watson and Deep Blue, but a large number of big tech companies. Hello? Well, I'm very loud, but it would be nice to fix this anyway. We just continue, we'll try to fix it after. Yeah, you have a large number of technology companies getting into the picture as well. I mean, I recall at a non-technical conference, the Singularity Summit, which is a futurist conference in, I think it was, could have been 2008 or 9. You had Justin Ratner, who was the CTO of Intel, got up on stage saying, yes, I agree with Ray Kurzweil, there will be a singularity around 2045. And furthermore, the singularity will have Intel inside. Intel is going to bring you the singularity, right? And, I mean, whatever you think of that, it was interesting to me that a big company like that was able to put themselves behind these crazy sounding ideas like there will be human level thinking machines transforming the world by 2045. I mean, of course, we all will have our own opinions on Ray Kurzweil's precise futurological extrapolations, but there's no way you would have had the CTO of a major tech company making that sort of public proclamation 10 or 20 years earlier. It would have been just too far out there, whereas it was almost taken for granted in 2008. And in 2014, it would be even more. So it wouldn't even be interesting now that Ray Kurzweil has been hired as one of Google's directors of engineering, who is now leading one of Google's internal AI research groups. So given all these developments and how mainstream the attempt to build thinking machines has become, one might even doubt why there's any value to gathering in this separate little room like this to talk about making thinking machines. I mean, it's no longer forbidden or thought so badly of in mainstream AI conferences or big companies. So what's actually the value of having a group of researchers gather specifically to focus on this when it's not such an oddball thing to do anymore? And we could just declare victory and say, well, hey, you know, all of us in this community played some role in causing AGI to become more mainstream and spurring all sorts of research and encouraging students and companies to work on this. And now the world is taking over. There's some point to that line of argument. However, I still think that an AGI community as such and conferences like this have a significant role to play. I mean, it's very exciting that the mainstream of academia and industry is embracing AGI and human level AI to a greater degree, but I still think we're still at a very early stage in the attempt to produce human level thinking machines. I mean, we still don't have a commonly understood paradigm in the field for thinking about what is general intelligence. Certainly there's a host of interesting cognitive architectures and learning approaches out there, but there's nothing that a significant plurality of the field is willing to put itself behind, let alone a majority of the field. So I think we're still at an early stage where foundational thinking and exploratory research needs to go on. I mean, alongside developing the ideas that are more mature into commercial applications and robustly working systems. So I think that at this stage, there's still a lot of deep collective thinking that needs to happen. And toward that end, I think it's important to gather together people who really want to think hard about these difficult problems. You going to say something, Paul?
When it's a good time, I wanted to actually have two comments to what you're saying. One kind of complimentary, one criticizing part of what you're saying.
Go for it.
When you're ready for it. Oh, okay. So, as your last point, as someone who comes out of the AI community, the hardware architecture community, the thing I very much enjoyed about this conference is its openness to new ideas in the early stage of development. It's still hard to find that in traditional conferences, even traditional workshops. So conferences have sort of become journals and workshops have become conferences. And a venue that will listen to a variety of ideas about AGI, I think is still critically important. And this conference does a real service to the field in being very accepting to that kind of thing. So it's one of the things I really enjoy coming here for is it gets me thinking in new ways, which to me is one of the most important things about going to a conference and workshop. On the criticizing side, I want to push back again on a piece of your history. You talk about the mid to late 80s. And although I know they didn't take approaches that you felt you wanted to take at that point, but really CMU was a hotbed of work on human level intelligence at that point. So there was SOAR, there was ACT, Jaime Carbonell's group was developing Prodigy, Tom Mitchell's group was developing Theos, individual grad students were developing architectures like Max. So there were at least 5 different cognitive architectures being developed at CMU in the mid-80s into the mid to late 80s after kind of the initial success of SOAR and ACT Star. So there was a community. It wasn't broad in the field, but we could publish in AI venues. So though it was also the heyday of expert systems, there was a good set of activity there. It had a peak, actually, probably at that point, and then went down later. But I think it's important to acknowledge that there was this big burst of energy in this area, in that, using different techniques, I admit, than many of the folks here use. But it wasn't as quite as much of a wasteland as you're trying to characterize.
All right, I can certainly accept that. I mean, as I said, at that time, without the internet and all the tools we have now, it wasn't actually that easy to understand what research is going on everywhere. So if you're a PhD student at a certain university, and every professor at that university says there's nothing to do in a certain area of science, it's harder to go beyond that at that stage than it would be now.
Yeah, I guess only the leading universities had ARPANET in those days.
Yeah, well, the last year of my PhD, which was early '89, we got email accounts at Temple University where I was. So that was just the beginning. Of course, there was no web then or anything. So yeah, I mean, not only that, but I mean, if you trace back, of course, all through since the late 1960s, there were people here and there doing interesting work toward AGI. I mean, if you look at Weka, the popular machine learning tool, that was based largely on, it was done by Ian Whitten and John Cleary at Weka University, where I was for a time in the early 90s. And John Cleary's PhD advisor was a guy named John Andreas, who was at University of Canterbury in New Zealand, who he wrote some very cool books in, it was either the late 70s or early 80s, on a system called Purpose, which was a bad acronym for something or other, but that was basically a Markov model-based natural language dialogue system that learned to have a conversation by a statistical model of what you type to it. I remember reading that book as an undergraduate. So I mean, University of Canterbury, there was a little group directly pursuing AI using statistical learning, which indirectly inspired Weka, which then played a big role in the machine learning world. So there actually was stuff going on all over the place, including the very important work you mentioned. But it certainly was difficult to find from the perspective of a PhD student at a random university at that point in time, which I think it's not that easy now either. I mean, people email me all the time saying, I want to do a PhD in AGI, where do I go? And then the answer is always quite complicated. But it's a much prettier picture now than then, anyhow. And yeah, I think Paul did raise another important point, which is that since we are at an early stage in understanding how to build human-level thinking machines, it's important to have a venue and an attitude of openness to many different ideas. I mean, we're going to hear a keynote speech shortly, as soon as I shut up, about deep learning, and which is extremely exciting and important. Thrilled to see deep learning getting so much press and having so many practical successes. On the other hand, it's quite premature in my view to jump on any one thing and say, well, deep learning is the sole core principle of building thinking machines, or my own approach or anything else. I mean, the successes that have been had so far with any approach are very limited compared to the grand goal of making something that can really think and act like a human being. So we still need to be open to many, many different ways of thinking and see what we can learn from them. Another idea that I think is important, which I think most but not all of the people in this room will agree on, is what I've tried to formulate as a sort of core hypothesis of AGI, although I haven't found a really great formulation of it. But the notion I'm thinking of is merely the notion that creating a human-like general intelligence is going to involve some principles that are different from the principles involved in making very narrow and task-specific intelligent systems. And this isn't 100% obvious. I mean, it might not be true. It could be the case that essentially a human-like mind, it's more like a Linux OS with a bunch of little programs doing very specialized things. And once you have 10,000 of the right specialized AI programs, all networked together, each solving their own specific narrow problem, then putting all these things together, then you get a human-level AGI. Or it could be that the principles of a human mind are very similar to the principles underlying, say, a supervised classification system or a logical theorem-proving system. And if that were the case, if there weren't any distinct principles to human-like general intelligence versus very narrow, task-specific AI, then the argument for having an AGI pursuit as something distinct would be much less. I mean, then you could say, well, we'll proceed on, say, supervised classification problems, we'll proceed on logical theorem-proving problems, and we'll incrementally make those better and better until they become generally intelligent in the sense of humans. On the other hand, if there's some unique principles to human-like general intelligence that you don't need for doing very narrow task-specific AI, then there's much more of an argument for AGI as a distinct sort of pursuit. And of course, none of us knows for sure the extent to which general intelligence really is a distinct entity with distinct principles. And I intuitively think it is, but I'm not satisfied with how I've formulated that hypothesis in the first place. So really formulating what is general intelligence and understanding how it's distinct from narrow task-specific intelligence, that ends up being one of the research topics of the AGI field, which many papers at this conference will talk about. But I think that, again, is one of the values that we have for a venue like this. I mean, we need to be working at the intersection of abstract theory, practical system building, theoretical cognitive architecture, application development. We need to be looking at the intersections of all these different things so that we can really understand what general intelligence is and how to build generally intelligent systems. And having started in this field thinking, I was almost the only one really thinking about this because it was so hard to find other people interested in the same thing. It's quite heartening to me at this point to see and know so many different people who are inspired by a similar passion to create thinking machines. And as Paul has pointed out, to become aware of so many different lineages and histories of people who have been deeply thinking about this over decades in different parts of the world from different points of view.